Hello all, let we learn in today's session subtraction using complements and signed binary number representation. As in the last class we discussed about your complements. So basically we are going to use these complements in digital computer to perform your subtraction. So there are two ways to do your subtraction using your complement method. So you can use your r's complement or r minus 1's complement. So while you're performing your two n digit unsigned numbers, so m minus n, so in a base r system we have to follow these steps. So first, so based on the complement method, so if it is r's complement method of subtraction, you have to calculate r's complement of your negative number, so then that is added to the positive number. So here subtrahend is n and your minus is m. N is a negative number, so we calculated the r's complement by using your basic expression of r power n minus n. Now I can rewrite this expression as m minus n plus r power n, as we are adding that r's complement to the positive number m. So we rewriting your expression as m minus n plus of r power n. So without using any subtractor operator, we obtained your difference between the two numbers m minus n in addition with an end around carry. So if your given minute is greater than your or equal to subtrahend, then only it will generate your the end around carry, which is r power n, so which must be ignored. And then if you ignore this r power n, then we obtain the difference between the two numbers m and n. So if your minute is less than that of your subtrahend, then that summation doesn't produce any end around carry. So since if it is r power n minus of n minus m, so your the difference in between the subtrahend and your minute would generate here it is in r's complement. To obtain your actual difference between the two numbers, we need to obtain your r's complement of your given number and assign a negative sign in front of your difference. So this is the method of your subtraction to be followed if you prefer your r's complement. So now I'll explain you this with a example. So 72532 minus 3250. So where you're given two digits are of first digit of 5-digit number, first number is of 5-digit number, second number is of 4-digit number. So if you're doing the subtraction using complement, both numbers should have your equal number of digits. So hence we can introduce a 0 in your most significant bit of your subtrahend. So if you introduce a 0, the value may not change, so your subtrahend become 03250. Now upon identifying your negative number, which is 03250, obtain your 9's complement. 9's complement is obtained by subtracting each digit from 9. So now if I subtract your each digit of your subtrahend from your 9, we obtain your 9's complement first. Thereafter I'll calculate your 10's complement. So 9 minus 0 is 9, 9 minus 5 is 4, 9 minus 2 is 7, 9 minus 3 is 6, 9 minus 0 is 9. So next plus 1 we are going to add. So if I am adding plus 1, then it will become 0 with a carry of 1. So 4 plus 1 is 5. So next I obtained your 10's complement of 03250, which is equal to 96750. So we are adding that to the positive number 72532, which generates your 6-digit number. So this extra digit which is generated upon adding your 5-digit number is called an end around carry, and this end around carry is ignored, and you obtain your difference is a positive one, which is 69282. So now let me reverse your number. So 3250 minus of 72532. Now your subtrahend is greater than that of your minute. So though your subtrahend is greater than your minute, it is a negative number, so we calculate your 9's complement of that. So in order to equate your number of digits, you know, first number which is your minute, so we placed a 0 in your most significant digit, and then we obtained your 9's complement, 10's complement of 72532. To obtain your 10's complement, first we have to obtain your 9's complement. 9 minus 7 is 2, 9 minus 2 is 7, 9 minus 5 is 4, 9 minus 3 is 6, 9 minus 2 is 7, 7 plus 1 is 8. So which is a 10's complement. So 10's complement of your 72532 is 27468, that is added to the positive number, so which is 03250. Now the addition summation, 0 plus 8 is 8, 5 plus 6 is 11, and then here 4 plus 2 plus 1 is 7, so 3 plus 7 is 10, so 2 plus 1 is 3. So summation doesn't generate your sixth digit, which is an extra digit. So this signifies the result is in itself, it is in tens complement. So in order to obtain, since my subtrahend is greater than your minute, I obtained a negative difference. So we assigned a negative sign in front of the difference, and we have taken the summation, which is itself it is in tens complement. Again we have to calculate the tens complement of 30718. So 30718 tens complement is 69282. So which generates a negative or the negative difference. Next, if I prefer the nines complement method of subtraction, I need to calculate nines complement of your subtrahend. So nines complement of subtrahend is, so now we need to equate the number of digits. So hence I can place here 0 in front of the subtrahend. So which is 0, 3, 2, 5, 0. 9's complement is 9 minus 0 is 9. 9 minus 3 is 6. 9 minus 2 is 7. 9 minus 5 is 4. 9 minus 0 is 9. Upon adding this to the positive number, we have here total 7 number of digits, and now if you prefer 9's complement, this end around carry must be added to the least significant digit. Upon adding this, so then we obtain your actual difference between the two numbers 72532 and 03250 is a positive difference, so which is 69282. So since my subtrahend is lesser than your minute, I obtain your positive difference. Next, we will reverse that, and the method of subtraction is 9's complement. So here when you reverse the number, 3250 is your minute and 72532 is your subtrahend. Calculate 9's complement of 72532, equate your number of digits of your minute with 5 digits. So now we place the 0 so in front of this, so then 03250 is your minute, and your subtrahend 9's complement is 9 minus 7 is 2, 9 minus 2 is 7, 9 minus 5 is 4, 9 minus 3 is 6, 9 minus 2 is 7. So is added to the positive number, then the summation result doesn't generate your end carry, which signifies your result itself it is in one's complement. To obtain your actual difference, so assign a minus sign and obtain your 9's complement of this summation. 9 minus 3 is 6, 9 minus 0 is 9, 9 minus 7 is 2, 9 minus 1 is 8, 9 minus 7 is 2. So this is your negative difference between the two given numbers of 3250, 72532. In your binary number system, so you could follow your 2's complement method of subtraction or 1's complement method of subtraction. In this example 5, we prefer the 2's complement method of subtraction because they have given here. So using 2's complement, so hence we have to calculate for the subtrahend 2's complement of your subtrahend or the negative number, and that is added to the positive number. So they have given the first bit with the x minus 1 and the second bit with the reverse their number as y minus x. So now in x minus y, y is the negative number, calculated the 2's complement. So 2's complement is obtained by toggling your ones to zeros, all ones to zeros and all zeros to ones. So then adding 1 to the least significant bit, then we obtain your 0 4 ones 0 1 is the 2's complement of 1 4 zeros double 1, and that is added to the positive number. Summation would generate the extra bit, so we are going to ignore that, and the remaining bits will give you the actual difference. Since here it is y is less than that of your x, or x is greater than of your y, so you obtained a positive difference. The second case, if I reverse the number y minus x, x is greater than your y, your subtrahend is greater than y. So if it is a negative number, we need to calculate the 2's complement of x. So 2's complement of x 1010100 is 0101100, and that is added to the positive number. So summation doesn't generate an end around carry. It signifies your subtrahend is greater than your minute, and your difference in order to obtain your actual difference. So this summation is itself it is in 2's complement form. So now to obtain your actual difference between y and x, so we have to calculate 2's complement of your summation. So 2's complement of summation 11041 is equal to 0010001, and assign negative sign because here x is greater than y, so you could get your negative difference. If you prefer the ones complement or radix complement, diminished radix complement, so then I need to obtain the ones complement of your subtrahend. The first case, so ones complement of 1, 4 zeros 1 1 is equal to 0, 4 ones 00 is added to the positive number x, then generates end around carry. If it generates end around carry, if you prefer ones complement, this must be added to the least significant. So this is forwarded to the least significant bit. So if I am adding that, so then I obtain your actual difference between your x and y, which is 0 0 1 0 1. Next, in the second case, so y minus x, x is greater than y, so your subtrahend is greater than y. So now we identify your negative number, which is 1 0 1 0 1 0 and we obtain your ones complement of x, which is 0 1 0 1 0 1 and that is added to the positive number y 1 4 zeros 1 using binary rules. We obtain your result 1 1 0, summation result 1 1 1 0. So 6, we have your 7-bit number. So this 8th bit is not generated after addition of your ones complement to the positive number, signifies your summation is itself, it is in ones complement and your difference is a negative one. So assign your negative sign in front of the difference as well as obtain your ones complement of 1 1 0 1 0. So ones complement of 1 1 0 1 0 is 0 0 1 0 1. So this is about our complements, using your complements, how to perform your subtraction. Next, how to represent your binary number in digital computer. So there are two ways of representing your number. As unsigned numbers we can represent, and as well as your signed numbers. Now in unsigned numbers there is no specific bit or any sign we have indicated for positive or negative number, whereas in signed and binary number representation we are going to allocate a special bit in your most significant bit, which denotes your sign of the given number. If it is 0, it signifies your positive number. If your most significant bit is 1, so it signifies your negative number. So now in order to represent a plus 9, so in your sign magnitude form with the 8 bits, so my most significant bit must be 0 and the remaining bits will give you the actual relative magnitude of your given number. So this is the way of representing your plus 9 in signed magnitude form, which is a positive one. But negative one is represented by putting your minus 1 on your most significant bit and the remaining 7 bits will give you the magnitude of your given number. So these 7 bits will give you the actual value of the number and this most significant bit will give you whether your given number is a positive or negative. So there are three ways to represent only the negative numbers. So signed magnitude, signed ones complement form and signed twos complement form. So signed ones complement form is obtained from your signed magnitude form. So sign bit is taken as it is, but relative magnitude bits are complemented. So zeros, all zeros are complemented ones and all ones are complemented to zeros. Then we obtain your signed ones complement representation of a negative number minus 9. So this is your minus 9 in signed ones complement form. This is the minus 9 representation in signed magnitude form. This is the third way of representing your negative number minus 9 in signed twos complement form. So this signed twos complement form is obtained from your signed ones complement form by adding 1. So when you compare these two, so if I am add 1 to the least significant bit, then I will obtain here 4 1 0 triple 1. So now in the next slide we have given here a table which is represented the positive numbers from 0 to 7 in all these three forms and negative numbers from minus 1 to minus 8. Their signed magnitude forms, okay. Next, signed ones complement form as well as your signed twos complement form. So now when I am observing this table here, signed positive number representation of positive number in signed magnitude, signed ones complement and signed twos complement is similar to each other, whereas the only difference in your representation of negative numbers are differ from one representation to the other. So signed magnitude form, your -1 is represented as 1001, whereas in signed 1's complement form it is 1110, 1110. In signed 2's complement form it is 4 ones. So like this we are going to represent your binary numbers using your sign bit. So in the next session we are going to discuss about your Boolean algebra. Thank you, ma'am.